Okay, folks, I got a lot of answers back on this video concerning this burned transformer in this Heathkit. Yes, I was kind of hoping to get more input from the newbie side of the house. That was the whole idea of it. I could see from the postings that most of you that jumped in on here, pretty much know what you're doing, which is great. There's a lot of good information for our young people, our newbies to learn. But I try to keep my videos geared toward the new people coming into the hobby, or the ones that maybe just need a little refresher now and then of something I might be able to help with. And I also like to keep them to the point where people on a budget. Okay, some of y'all said, well, you need to get this and do that and get, well, that stuff costs a lot of money, folks. You probably already have that stuff on your workbench, but a lot of the young folks that I gear my videos to, they don't have this. They don't have a whole lot of money to spend on it. So I wasn't geared in that direction. But one thing I noticed about a lot of these comments, okay, we in this hobby have a tendency to overthink things, okay? I'm one of these guys, I'm not smart enough to overthink. I have to keep it simple. Tell you what, let's take another look at this transformer. I've got it all cleaned up, as you can see, best I can. Got a lot of what's called the carbon trails off of it. And this piece of wire right here, if I can get my pencil in the picture, there we go. This piece of wire right here still has its insulation on it. This one does not, okay? And it directly goes across this thing right here, that shiny thing right there. It kind of looks like a wire at first. But if you go to the left here, you see this great big old thick piece of wire that's soldered to this thing. Okay? Now this big old thick piece of wire runs up and around and down underneath this paper here, and it shows continuity to this copper wrapping around this transformer. Take a look at that. See, it goes all the way around and joins right there. It goes all the way around the other side. Okay? See it? Here it comes. Right down around there, all the way around. Well, I guess it's two halves. Okay, it's two halves. Anyway, it goes all the way around. Now, what the heck is that, Well, I'm going to tell you what that is. That, ladies and gentlemen, is a shield, a metal shield. Let me get down here. It's kind of hard to focus here. It's a metal shield between the primary and the secondary coil of this transformer. And it's not on the schematic. You're not going to find that on the schematic. It does not show that shield, okay? All it shows is the soft iron core, which is down in the center of the transformer that this thing is wrapped around, okay? Well, now that presents a whole new picture on this thing. I remember when I worked on an Atwater Kent 856. I ohmed out all the wires. That was my really first great big restoration. I ohmed out all the wires, and when I got all done, I had a black wire left over. And I said, what's going on here? It was actually my first foray into ohming out a transformer lead of any kind. And I got on the antique radio forum, and I asked the guys here, I said, hey, I got this black wire left over that had, it came out of the transformer, out of the clamshell, just like these. But it went down and it soldered to the chassis. But every wire has been accounted for except that black one on the schematic. What's going on here? What's this wire soldered to the chassis for? Well, nobody had an answer. And I said, well, this is interesting. Why is nobody at the Antique Radio Forum have an answer to this? So I dug around on the internet, checking this and checking that, and it took me quite a while, and I finally realized by going to one website that there is a metal shield between the primary and secondary windings of in some transformers, not all of them, in some transformers that prevent arcing. If any arcs were to go between the primary and secondary, it would hit that metal shield and be taken to ground. Well, that's what that black wire was on that Atwater Kent 856 transformer. It was the shield wire. Well, guess what we have right here? We have the exact same thing. This wire is coming out from the shield where it's soldered. If I can get a little focus here. Kind of difficult. Oh, there we go. It's soldered right here. It runs out and it's connected. It has continuity to this right here. which in turn has continuity to this right here, which in turn has continuity to the chassis once it's bolted up. So there's your shield wire connected to ground. Any sparks or arcs take place or attempt to take place between the two windings, it's stopped at this point on this piece of metal. It goes all the way around, all the way around, all the way around, and it's taken to ground. Now, isn't that cool? Now that we understand what this is all about, by the way, it's not connected. There is no connection between this right here, and there's no connection to this ground wire right there. It's separate, okay? That ground wire is connected to the winding on the secondary. This wire right here, this was a construction problem that they had. This wire right here that you see without any insulation on it was draped directly over the top of this metal thing you see. That is soldered to this wire that goes to ground. And this wire, which was real black when we first started, was barely touching that thing, just enough to give us an arc, just enough to cause a short. And this wire is the primary. So what am I going to do? Well, I'll tell you what. I'm going to slide some cardboard up underneath this thing. I'm going to lift it up a little bit. I'm going to slide some cardboard up on there. Well, first I'm going to spray it real heavy with some enamel. I'm going to let it soak all down in the, in between. We have nothing to lose at this point. I'm going to let the enamel soak all the way down in there as much as I can. Just let it drip on down. And then I'm going to let it set overnight. The next day I'm going to slide some cardboard underneath here. We're going to insulate as best we can this wire from that shield. Okay, I'm going to make sure that wire is away from that shield before I do all this. I'm going to slide that cardboard as deep as I can and make sure there is a big separation. Essentially what we have right now is this wire is that wire. We can't have that. So once I get that cardboard slid in under there, I'm going to go ahead and spray it one more time with enamel, clear enamel. And then guess what? We're going to reconnect this transformer back up. We're not going to put it back into the Heathkit body of the oscilloscope, and the chassis. What we're going to do is we're going to hook up everything minus one or two connections that we know we don't need for checkout purposes. We can check it out afterwards. I'm going to gator wire this baby in. We're going to gator wire it in. We're going to bring it up on the variac, and we're going to see what happens. And hopefully there won't be any more sparks right there. Alright, we have sprayed this real heavily down there with enamel, just clear enamel, like I said. We just let it run everywhere down in there, and as you can see, it's nice and shiny. And most of those carbon trails are gone, as much as I could make go away. Anyway, the last couple of days have been pretty good around these parts. We, of course, had Christmas. And I haven't been out to the movies for a while, so I went and saw a couple of movies. Went with one of my grandsons, John, to see Creed. Boy, that was a good movie. I enjoyed that. And then today I went with great-grandma, and we saw the new Star Wars movie. And that was a lot of fun, too. She enjoyed that. We watched it in that 3D. That was real good. Anyway, we've gotten now to the point where we need to insulate this wire here from that shield. So here's what I've decided to use. I was going to use cardboard, but I decided to just go with this piece of plastic that I cut. I'm going to go ahead and slip it underneath here like so. We got big storms going on, by the way, through Arkansas today. I'm going to go ahead and slip that through there like so. I want to get it up on top of that big wire if possible. Let me see if I can get that done. Come on, baby, get up there. I guess you don't want to go. Let me work at that for a minute. Well, there she is. Now what I'm going to do, it's totally insulated, this top wire now, from that shield. That shield is right there. I'm going to shove it back a little bit further as far as I can go. And I'm going to take one of my little jeweler's screwdrivers here. It's got a very thin blade. I like that. I'm going to dip it in this liquid tape. Just get a little bit on the end. I'm going to put a little bit of it underneath this end of it. Let me see if I can get it to focus. There we go. I'm going to put a little bit underneath this end and a little bit underneath this end. And we're going to permanently put that in there, and we're never going to take it out. You know, at the most that's going to happen, the transformer is going to be thrown away, and that's going to go with it. Hopefully this will solve our problem, and we'll find out shortly. Well, there she is. I decided to put just a little bit more on the right hand end there to kind of cover up that wire and protect that one too. Now we just let it dry. Well, she's pretty dry, I guess, and it's not going to go anywhere. And you know, if you take this tape that was here originally and you drape it down over there, you can see right where that wire is. That's where it was burning. So I don't know, maybe we can make this thing work after all. Sure would be nice. We're finally at the point where we're ready to go ahead and gauge the wire this transformer back in and fire it up and see what happens. But before I do, there's one more thing I want to cover. You'll see right here is a half-wave rectifier, and this is a full-wave rectifier coming off the transformer. This is a half-wave. Now that half-wave output goes through a pi filter here. Okay, we've got both of these capacitors are connected to ground. They're 0.1 microfarads and they're rated at 1200 volts apiece. And the purpose of that is they want nice smooth voltage coming off and going up here, feeding the grid and the horizontal vertical plates on the CRT, as well as the filament. So what happened was one of them had gone bad at one time apparently, and whoever owned this scope previously replaced it. Okay, they put in an orange drop deal in there, and here's what they looked like originally. Now look at the size of these things. These things were gigantic. A 0.1 1200 volt DC working voltage capacitor. This one here I tested on the capacitor tester that my mentor, my electronics mentor Brendan sent me. This thing is dead as a doornail. Well, it doesn't do anything. It just lays there. Anyway, of course, it could be you know, that the voltage I couldn't take it up to its maximum voltage because the tester, the way I read the tester, it only goes up to like 600 volts, but still nothing happened at all. Anyway, it's no good. It's not going back in there. And lo and behold, I was going to go ahead and have to order one. There was going to be a 2-week delay, and there's still going to be a delay anyway. But guess what came in the mail today from our good subscriber Don up in Ohio. Oh, I'm a junk collector. He saw that I was in need of a high voltage capacitor. I couldn't believe it. I don't know how he saw that, but right through the mail today comes this one here. Now the capacitance isn't exactly right. This is a 0.015. It'll work though because it's rated at 2000 volts. And that'll get us back in business, you know, for a checkout. All I have to do is solder it from ground over here over to this lug right here. So I'll have my two capacitors as part of that pi filter network. We'll have it all set up, and there's the resistor, by the way, which is between the two capacitors that you see right there. Okay, so let's get all that soldered in. The capacitor is now in. I've soldered it in, and we're about ready to go here. But you know, there's also one more step we have to do. Now, you young guys that are just starting out, or get your bottle of alcohol, get your acid brush, cut it down a little bit so it's a little bit stiff, dip it in there, and when you're done soldering, you've got to clean these solder joints, okay? Get those solder joints cleaned to get that old nasty old flux off there. It's all part of being a good repairman. Some people, they just get lazy. Oh, I don't need to do that. Just get it done and get it over with. I'll tell you what, if you continue to do it time after time after time after time, you don't even think about it. It's not considered a chore. It won't even enter your mind as being something extra you don't want to do. You just naturally do it, just like heating up your iron, getting ready to solder, okay? Just something we do. There we go. She's nice and clean and ready to rock and roll. Now let's get it hooked up. I'll tell you what. One of my philosophies has always been in all the videos I've done is, don't get in a big hurry when you get toward the end. And I'll tell you what, it's a little bit late at night. I'm not going to get in a hurry. Now is the time to slow down. When you get toward the end of any project, don't speed up. That's the time to slow down. It's the next morning, and I've got everything wired up. Everything is just gatered in, and I put a 1.5 amp fuse in here. Just to, the fuse size doesn't matter at this point, as long as we have some continuity. I could have put a jumper wire across there, it didn't matter. I'm interested in seeing the tubes light up, of course, but I'm most interested to make sure that there's no smoke coming from this area right here. Now there is a possibility that shield could be shorted to some of those windings down in there very deep, and as soon as I start bringing the voltage up, it'll start smoking right away. If that's the case, then we're out of luck. That'll be the end of it. Hopefully it won't smoke. Hopefully hopefully we'll get some kind of a little raster here on this little scope, and the tubes will light up, I hope. So let's go ahead and turn on the old variac. I'm going to bring it up slowly, and if I see any smoke at all, that's going to be the end of it. Let's take it up maybe 15-20 volts to see what happens. Alright, there is, well, we'll take it up to 30 volts. There's 30 volts. Got a little bit of current draw so far. Let's see what happens. Let's take a look at our transformer. Well, so far so good. So far so good. Let's take it up to 50 volts. Well, there's 50 volts. No problem yet. Let's go up to 70 volts. 70 volts, no smoke. Looking real good so far. Let's go up to 80, maybe 90 volts. Let's just go for it. What the heck? 90 volts is next. Well, there's 90 volts. So far so good. I don't think we're getting any filaments lit though. Let me turn this light out. I should have some filaments in the tubes lit. Let me take a look at it here. Nope, we're not getting any filaments lit. This is not looking good. Shucks. Well, so far our current draw does show some filament. Either that or I've got another little minor short. I'll tell you what, I'm going to take it up to 100 volts. Let's go to 100. There's 100 volts right there. Current draw is still looking pretty good. Let's look at our transformer. She is holding. Now at 100 volts we should get something on this screen here. Let me back up. Let's see. Let's turn off this light. Maybe we'll get something faint glow or something, even if the tubes... Well, son of a gun. Look at there. Look at there. Look at here. I have the CRT lit up. I don't see any other lights though. This is not good. I may have to go back and double check, but we are getting a CRT lit. That's always good news. Let's turn up the intensity here. Ooh, 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 look at this. All right, we're getting a beam, but nothing else is working. We're getting a beam. How about that, huh? I don't want to burn the back of the scope. It's already got a little burn mark there. All right, we're making some headway on this thing. How about that? We're now at 120 volts and we're not seeing any smoke. By golly, I think we got us a convoy on this thing. Now, of course, if the filaments will light up, I don't know why, but anyway, apparently the fuse is not blowing. You know what? I think what I'm going to do is call this a success so far. Until we can get those filaments to light up, I got to find out what the problem there is. I'll check out the entire circuit, which is generally the case, you know. You wire up something like this after you've gone ahead and repaired and repaired and repaired. It almost never works on the first try, you know. You got to go back and find out what the problem is. Alright, so why don't we just go ahead and wrap up this one right here. We'll call this a success until I can get the filaments on. By the way, speaking of successes, I received a Christmas card from our good buddy and my mentor Brendan and his wife Ann up in Detroit. a nice little card. And I'm glad to see that. It's her handwriting, obviously. No guy could write that well. Anyway, I'm glad to see that. That tells me old Brendan's still on the mend, I guess. And that is a load off my mind. All right, and one more thing. I received a nice card from our old buddy Martin Carson. He's like 82, 83, somewhere in that area. He lives out in Atlanta, Georgia. He's the one, remember a while back we restored this Philco radio that belonged to Martin's grandpa, who had been born in 1879. And he sent a nice card, and he said he watches every one of my videos. Every time one comes out, he never misses it. So I'm glad to see Martin's doing well also. So thank you very much, Martin. Anyway, folks, next time we hope to have even better success with this scope. So until then, this is John. Well, I've got the scope upside down, which makes it a whole lot easier to control where my gator wires are going. But check this out. Yes, check that out. Bright and dim. Up and down. I mean, come on. Come on. It doesn't get any better than that. Left and right. Look at that. Man, that's good. That's really good.